Hello, welcome to another edition of Cracking the Cryptic, where today we're going to take a look at a puzzle that's been sent in by a viewer, and it's a puzzle they've created themselves. And Laura Solar has sent this in, and you can see she describes it as a partial killer Sudoku. I guess it could also be called a sort of irregular Sudoku, in the sense that there are all of these coloured regions that need to contain the numbers. This is part of the trick, I think, to solving it. I've noticed that all of these regions are 9 cells large, so in effect we need to put the numbers from 1 to 9 in all of them. Now, if you want to try the puzzle, click on the link under the video, and that will take you here, where you can have a go too. And you can see I'm staring at it now, just trying to work something out. Right, I have spotted something actually. Let's just talk a bit about this. Yeah, if we count the number of coloured regions, you can see they're all size 9, and we've got 1, 2, 3, 4, 5, 6, 7, 8 coloured regions. So that means that there are 8 regions size 9 that contain the numbers 1 to 9. Now that means that these white cells in the grid form an additional region, in the sense that there must be the numbers from 1 to 9 in the white cells. Now you can see some of the white cells are already filled at the start, so that might be important for the solve, is to realise that these white cells all need to be different numbers. Now let's have a look at how to do this. I can see that this 7, 4, look, that's going to give us 7, 4 into these two squares, and there's a 7 at the top, so in fact we get to place a 7 here. This must be a 4. There must now be a 7 in one of these two positions. Yeah, okay. Okay, yes. So now this blue region here already contains a 7. So this 7 becomes super powerful in terms of this block, because we can't put a 7 in the blue squares, we can't put a 7 in the yellow squares. So this is a 7. And over here, this must be a 7. And the reason for that is that we have a 7 here and a 7 here. This 7, or a 7 in this square, clashes with the 7s we've got pencil marked down here, and there's a 7 in that position. So we actually get to put, maybe on our way to placing most of the 7s here. If we look at this block, I know this square cannot be a 7 because of the logic I explained at the beginning about the white squares. Now this square can't be a 7, so this is a 7. And now, yeah, okay, and this 7 is a beautiful puzzle, isn't it? Because now this 7 sees these two 7s, so this is the only place for a 7 in this block. Now that unwinds the 7s on the right hand side of the grid, and there must be a 7 here finally. So actually we're able to complete all the 7s due to the sort of intricate way that these shapes interact. So which number should we pick next? Well, I can pencil mark some 5s down here, so I'm going to do that. 5s to those two squares because of the 5 here and the 5 there. And that means there's a 5 in the blue area. Now, what else? Can we do anything with... yeah, yes we can. This area here, because of this 5 sees this square, but it also sees these squares at the top because it's in the yellow shape. And this 5 means that this is a 5. There's a 5 in one of those two shapes on the... It's either in the red shape or the purple shape. And there is a 5 in the green shape up at the top there because of this 5 and this 5. So there is not a 5 in either of these two squares. And there's not a 5 in this square because of this 5. So there is a 5 in the red squares in one of those two positions, which means this square cannot be a 5. This is a brilliant puzzle. I can't remember if Laura said this was the first puzzle she has made, but if that's the case, this is extraordinary. Now, can we go any further? Yeah, well, maybe. 5's on this block now, must be in this yellow shape, I think. Oops, no, I didn't mean to do that. Like that, which means this is not a 5, which means this is a 5. Now that means there's, well, we knew there was no 5 in those two positions anyway. So which blocks have we not got 5's in then? We've got 5's here. Ah, these two 5's see this square. So this isn't a 5, this must be a 5. So we just haven't quite unwound how the 5's look on the right hand side of the grid. Just stare at this for a moment in case there's, I don't think there's going to be a way of resolving that. Well, never mind, let's move on. Well, this 1 perhaps. The reason I'm looking at the 1 is it obviously we can't have a 1 in any of those squares. So the 1 in this green area is locked into row 1 and row 2. It's up there somewhere. Oh, in fact, we've got the same trick going on here. This 1, obviously, it sees these 3 blue squares and it sees these 3 squares just because they're in the same row. So we get to lock a 1 into one of those two positions, and that means this square is a 1. And now if we look at the interaction, because these two 1's here see that square, there's a 1 in the purple area. Oh, that's not great, is it? Well, it's not great, except that these 1's in the purple area see this white square. So we know there is a 1 in one of the white squares. Now, which square is that? Can't be this square, can't be this square because of the 1 here. It can't be this square because we know there must be a 1 in the green area, and we've pencil marked it there. And it can't be here for the reasons we've just... So I think this square, if the logic is good, this square has to be a 1, and that means this square. What a brilliant puzzle, this square now. 1, 1, and now this square's a 1. Now this is not a 1. This square is a 5, which means this, good lord, 5, and this square's a 1. This is an incredible puzzle. Right, so now I guess there is a 1 either here or here. This 1 sees that square, so there's a 1 there. And there's a 1 either here or here. Okay. I guess that's good. Which colour is that in grey? Isn't that a white square? I don't know why that looks like a bit different. Right, okay, but it doesn't now. So we've got 5 numbers in the white squares. Into the white squares I need to put the numbers 3, 4, 8, 3, 4, 6 and 8, I think. And there's a 3 and 4 here. So there must be a 3 or a 4 in this square, and a 3 or a 4 in this square. Can I see how to eliminate those? Not immediately, but this must be a 6 or an 8, and this must be a 6 or an 8. Okay, so I've now got 6 digits in column 8. I need to put the numbers 2, 5, and 9 into the O. Well, this has to be the 5 now. I could have got that before because it's already seeing, well, there can't be a 5 here, there can't be a 5 here, because of these two 5s. Now I need a 2 and a 9 into the remaining positions in column 8, so that's a 2 or a 9, and this is a 2 or a 9. I might have to pause in a second, but I shall come back to this momentarily. Okay, sorry about that, brief pause. Right, now I've got to get my train of thought back. We were looking at 6s, 8s, 3s and 4s. Well, 4s... yeah, 4s are interesting. Look at this funny yellow shape here. Where can we put a 4 in this shape? This 4 rules out a 4 from these two positions. This 4 rules out all the other positions except this square. Now that is useful because that gives us a 4 here, and that means this is a 3, and that means that square up there is a 4. This bizarre sort of, it's almost going down a wormhole in order to prove that this is a this digit here affects this one, but it does. Now, okay, so all of a sudden we've made better progress with 3s and 4s, so what can we do next? I guess I'm going to look at this column because I've got 6 digits in it. I need 3, 8 and 9. So this square can only be 8 or 9. This square is 3 or 8, and this square is anything. But this 8 is important because, well, it interacts with this 8. It locks an 8 into one of these two squares. Oops. And therefore this square can't be an 8. That's going to have to be a 9. Which means that this is a 3 or an 8 as well. Now, can we do anything with any more with this 8? Well, I can pencil mark 8s into those positions like that. That means I can pencil mark 8s into these two positions. And 9s now, yeah, this 9 as usual. All of these shapes are so weirdly interdependent. So this 9, although it sees the middle row, obviously it sees these two squares as well. So there must be a 9 in one of those two positions, and that means this can't be a 9. That must be a 2. That means that this is a 9 at the top. Now, does this 2 give us anything useful? Yes, this 2, believe it or not, means we can fill in the 2 in the middle box, because it can only be here. Because this 2 sees all of the red squares. And therefore there must be a 2 in one of those two positions on the left hand side. Still looking for 4, 6 and 9. So there must be a 9 either here. This can't be a 9 because of the 9 up there. So that square is a 9. Which means this square is a 9. This square is a 9. Now there's a 9 in the green area there. 9, and there's a 9 in the yellow area at the top in one of those two squares. Now these two should be 4 and 6 in some order. Don't know how they unwind yet, but we obviously need a 4 and a 6 in this top right hand box. So this square here is going to have to be a 6 now, because it cannot be an 8. I need the 4 and the 6 to occupy these two positions. So that's a 6, which means this down here is an 8. This is a 4. 6. 2, 3 and 8 into these positions. So I'll just highlight those. And, I will if it lets me. 2, 3, 8 like that. 2, 3, 6. This is a 2 or a 6. Again, I'm going to highlight some of these things just to try and keep track of it. Now this square here can't be a 3, so this must. So is this Yeah, so that square is the only place a 3 can go in the row, which wasn't obvious to me, but is true. So that gives me a 2-8 pair here. And I suppose I've got 5 digits in this funny blue shape. And I must need 2, 3, and 6 to complete this square down here. Now, again, sorry, I'm sort of muttering to myself, but I'm trying to do this in the most efficient way, and I'm sure I'm not succeeding. But this 8, look, that sees that square, which I've pencil marked, so that can't be an 8 anymore. That moves an 8 into the yellow square. And now we need 2, 6, and 8 along the bottom. You can see that's going to resolve the blue square on the right. So 2, 6, 8 into those squares. This square here, therefore, can only be a 3. And this 2, 6 now sees that square. This can't be a 2 anymore. I have to say, this is a really superb puzzle. One of the privileges, I think, of doing this channel is some of the puzzles that you send us that you've created yourself, and this is one of the very best that we've been sent. So real kudos to Laura. Now I've done the yellow shape. That's good. And in this green shape down here, you can see I need the numbers 6 and 9 into these 2 squares. Now I can put the 6, 9 in, but now this square is forced. This can't be 8 anymore anyway. This is going to have to be a 4. Not 4. What's it going to be? 8. Oh, hang on. That is an 8. For some reason I thought it wasn't. I think it is. 8, 8. Now this square here looks like it's got to be an 8. Yeah, I could probably fill that in before. I'm not quite sure why I didn't. And in the purple area, I'm still looking for a 3 and a 4. So this will have to be 3. This will have to be 4 now. Just need a 4 in one of those 2 squares. So that's 4 and 9 in that order. This square at the top now must be a 4. This square here has got to be a 6, I think. That resolves the 6 and the 4 on the... this cursor's really weird on my laptop at the moment. And are we nearly done? Well, we're making good progress. I think we've cracked the hardest part of this. This square here must be a 6. It's the only thing it can be. Which means I need 2 and 8 into these 2 positions. So that's an 8, that's a 2. This is now a 2 here. In the blue area here, I still need to put a 1 and a 3 in. So that's a 3, that's a 3 here. This is a 1 or a 3. You can see we've got the 3 in that position. So this is a 1, this is a 3, this is a 1. This must be a 6, I think. Yeah, I'm not sure about the logic I used for that square. I don't think it's going to matter terribly much actually, because that square has to be a 6 anyway. So that, yeah, there was a 1-3 pair there, but I'm not actually sure that what I said was quite right. But I don't think it's going to make a massive difference. It looks like it's going to unwind correctly. 6 here. So in these 2 positions here, if everything's going according to plan, I need a 2 and a 9, which makes this a 2, this a 9, this a 9, this a 6. Let's check it. It's all good. What a wonderful, wonderful puzzle. I hope you guys enjoyed it. I expect to see lots of plaudits for the setter in the comments if you did. And we'll be back soon with another edition of Cracking the Cryptic.